Junior Cycle Higher Level 2015 Sample Paper 1 Question 1. This is a sets question, and they give you a Venn diagram drawn out already with P, Q and R already drawn and elements included, and you have the outside universal set as well. So they're just asking you to, straightforward question, asking you to list elements. By that it means what numbers, what elements are inside each of the prescribed sort of sets or subsets. So the first one here, we have P union Q. So where's that space? Union is all of whatever's in P and also in Q. So it's sort of just adding together everything together. So here we have elements of 1, 2, 3, 4, 5 and 6. When you write out your lists, you should put curly brackets either side, and you should just mark out any elements with a comma. Part 2 is asking for the intersection of Q and R. That's sort of a downside end shape. That means intersection. Intersection is the overlap or the crossover of two sets. So of the elements Q and R, the overlap is this section in the middle. And so we have elements 5 and 6. And for the last part, we're asked about the union of P with Q intersection R. You can see these two brackets. These are important. When you have a sort of complicated expression involving set notation, and you have part of it is in brackets, what you should do in the first instance is to focus on that section that's inside the brackets and think about what that means, and then you can start saying, right, okay, using that part along with P, what is that in this instance, the union. So there's Q intersection R, and we're going to union that with P. So we have P, and if we want the union of it, we're wanting all of that all together. So that's elements 1, 2, 4 and 5 from P, and we're unioning that with whatever is in Q intersection R, which is 5 and 6. Please note I haven't written out 5 twice. I mean, 5 appears in both 1, 2, 4 and 5 P, and it also appears in 5, 6, i.e. Q intersection R, but you only ever write an element once in a list. You should also note with these questions, often they're helping you, and you'll have seen that what I was asked to look at here was connected to what I'd been asked, or certainly part of what I'd been asked to previously. So what I had worked out as Q intersection R, whatever you'd written in there, if I then unioned that with P, I would have got the marks. But always look at the previous parts that sometimes help. This bit here doesn't fully help us because it's starting to confuse us between P union Q and P union Q intersection R. But just be mindful of whatever was written prior. That sometimes helps your focus in terms of where you're looking at. And moving on to part B, we're asked to look at P unions with Q intersection R. So again, this question is getting us to think about what we've already been thinking about. So we have this sort of shaded intersection. That's what we're thinking about. So, and it's asking us to look at the concept of distribution within sets. So it says union is distributive over intersection. Well, firstly, I suppose it's worthwhile just mentioning the concept of distribution. In algebra, you use this often, or in number theory, we use it. So, for example, if you had this as an expression, you were asked to simplify it, i.e. open the brackets. The 2 multiplies by the x and also multiplies by the 4. So we get 2x plus 8. And that process is distribution. Multiplication is distributing over addition. So in set theory, when they're talking about union distributing over intersection, as the statement gives, if we look at this one, we're talking about the union of P with what's inside the brackets. distribute over each of those two parts. So in the exact same way as I did with my algebra, I can do with this with the set notation. So P unions with Q, and separately P unions with R, and then because the Q and R were intersected, then we have these two separate sets intersected. Just like we did here, 2 multiplied by x and 2 multiplied by 4 to give you 8, and then we're adding our two separate parts together. Here, P unions with Q, P unions with R, and then we intersect our results.